Okay, so in the previous video, I tried to explain the logic of how to solve the second questions, that we need to understand that we need to find the period from the omega, the angular speed from the centripetal acceleration, and then we need to find the centripetal acceleration from this one, the F net, and in order to find the F net, we need to analyze the free body diagram that we had, and we need to apply the parallelogram method to find the F net. Okay, so on this page, I just like try to rewrite them to just want to show that to make them like cleaner, nicer. So summarize again. Motion of the seat, the person in it, is a uniform circular motion on a horizontal planet. So the F net acts as a centripetal force and will keep everything moving around in a circle. Like this, and then it's always like acting towards the center at any point. Like if this travel there, it will be like toward this. So it's a centripetal force, and as a centripetal force, then we can find the acceleration, and then from the free body diagram we can find the relationship between them. The F net equals to the weight here times with tangent of the opposite angle to the F net, because this is a right triangle, and then we just plug in these values. F net here, oops, sorry, so the F net here will be like the total mass times with the acceleration. The weight here will be also like the total mass of the system times with the gravitational acceleration, and then the tangent of the angle 30 degrees. So this is the one. Okay, and actually, like in most of the problems, you may find this relationship a lot of time. Okay, so then from this one, we just plug in here the AC here, you see. And then if we know the radius, we can find the omega. So what is the radius? The radius is the radius of the circle, so that should be this whole length, right? That would be include the 3 meters here, and then another segment here. And actually this one, do you realize that this one also another right triangle? This one, you see that this is also another right triangle, and this is the hypotenuse, right? This is the angle, right? So can you find this one? Yes, you can, right? You just got the hypotenuse times with side of the 30 degrees here. Then you got this one, you sum with this one, then you got the whole radius to be 5.5 meter. Then you plug this back into this one, and then you got the G is 9. Okay, let me write it. So G, oh, sorry. So the G is 9.81 meter per second square, and then you just use calculator. We are allowed to use a calculator. So then we got the result to be 6.19 seconds. That's the period that we are looking for. Okay, last question. Does the angle depend on the weight of the passenger for a given rate of revolution? So basically, what do they ask? They just want to ask if the angle depends on the weight of the passengers, or like on the mass of the passenger. So can we get the answer? The angle that they want to ask here is the theta angle here. And we see very clearly from this one, right? From these equations here, from the relationships here, the mass cancel each other on both sides, and the tangent, the angles here, actually it just depends on the acceleration and the g's here. It does not depend on the mass, so it's just no, it does not, because it's independent with the mass. And yes, that's it. So that's everything for the giant swing problems, and I hope that next time if you give this game a chance, you will think of something about physics in this game. For me, I will think about it. Okay, thank you.